So yeah, so to put this into context, there's been an announcement saying that there was a new version of this MBMS transfer function. So when I saw that, what I did is that I went through this tutorial to actually try the examples. And what's happening is that this MBMS is sharing the same transport layer as what we are using at DVB native IP, meaning we're using FLUTE protocol. And at DVB-NIP, we've got VNV task force where we develop a DVB-NIP analyzer to actually analyze the so the NIP stream, but any FLUTE streams to see how files are actually transported and also what are the parameters used during the transport. And I try to use this tool to analyze the output of the MBS TF application. Okay, so basically, on my computer, I do have an Open 5GS running, and I can start the MBS TF application. So I'll start it. Starting it now. And then what I can do is that I can ask to ingest on the stream dash live MPD. So I've got a local live sim running on my computer as well with a live stream. So actually I will configure the server to ingest this. So I need to call curl. Okay. So then we see that the server starts to ingest and start to broadcast IP packets with the live stream. So now I can actually use the DVB Analyzer tool. So the DVB-NIP Analyzer tool is available on Docker Hub. So it's actually the path actually SES systems/DVB-NIP Analyzer. So I can just run it using the Docker. I'm running it with a network host so that the tool can have access to the local network of my machine. So I'm running it, and when you run the tool, it opens a port 8000 with a web interface. So this is localhost, and the tool is running. So with this tool, we can analyze files based on a pickup, or also directly a network interface. So here we are streaming packets to localhost. So I will actually analyze my localhost interface. Just few parameters that this tool is actually calculating bitrate, and we can define what's the average window to calculate the bitrate, how many times we want to do this calculation, and also how long we want to store the samples and all the metadata that the tool is collecting. So here we are collecting 2 minutes of data. We are storing 2 minutes of data. So I'm starting the analyzer. So it is starting, and then I can go to this. So it's called NIP Tree Explorer. And when I open this page, I see that the tool detects one FLUTE session. So the FLUTE session is actually transported on this multicast towards 32.0.0.1 at port 5000 with a transport session ID that is 0. And we actually see here, I pause it, we can actually see here in real time the bit rate of this session. So because it's transporting a live video, so we are transporting segments of 2 seconds, so in a chunk. So here we see that there is one chunk of video that is being transported, and then a second chunk, and then another chunk. So we can see in real time the bit rate, and we can also go back in time if you want to if you see something interesting or to analyze something else. So when I click on this session, we can actually see all the files that are transported inside this FLUTE sessions. So there is one file which is the FDT. So the FDT is the table that it is transporting metadata of an object, like the file name, the content location of the object is transported, and also the content type, some D5, what's the size of the object, and how the object actually split it into block and a packet. So you can actually see this file. You can see how many times this file is repeated. So each bar you see here, it's when a new FDT is emitted. So each time there is an FDT, then you see it here. And we can also have information about how this FDT has been transported into FLUTE. So, for example, size of the block, size of an encoding symbol. So so in this FLUTE carousel, there is then a dash manifest. So again, we can see actually the metadata, like the content location, which TOI has been used to transport the MD5 of this file. We also have some statistics like what's the bit rate of this file when it has been transferred, and how often this file is repeated. So here we broadcast a live stream with a segment of 2 seconds, and this file actually repeated as well every 2 seconds. For the dash manifest, the tool is able also to verify some timings. So for example, the manifest has a dash clock that is signaling the availability of segments. So each dot that you see here is signaling the availability of a segment with a specific number. So here we see the content location of the segment, and when this segment is supposed to be available. And the bar here represents the time or the when this segment has actually been received on the analyzer. So for example, this segment was signaled at minute or second 38, and it has been received second 38 plus 300 milliseconds. So it means that if we want to play this MPD properly, we actually need to delay the time by like 100 milliseconds to actually be in sync with the segments that are coming. So we got the same for so this live stream has a SD representation, HD, and also audio. So we do the same for the three representations. So the 300 milliseconds here, you see that actually the transfer delay of the segments. So it takes time to transfer the segments, and then you see that there is a propagation delay. That is added here. So we can actually open statistic of the carousel and see actually all the files that are received in this carousel. So each bar you see here, it's different file. Can zoom a little bit. So when we zoom a bit, so yeah, so the 8 here is actually the size of the file. So for example, this big blue box is actually the HD segment. That is, so it's a few 1.5 megabyte. And then this smaller one is the SD. And then we've got other small file, like we got from probably the audio as well. That is smaller here. So what we see is that, okay, I zoom again a bit more. What we see is that we start to receive an FDT. The FDT is signaling then the transfer of an audio segment. Probably there is another FDT again, small one here, and then it is signaling the transfer of an SD segment. And then here we see again another FDT that is signaling the transfer of the HD segment. So it is sent here. It is sent into as a burst. So as you can see, we transfer a burst of segments, and then there is no data anymore. And then we transfer the next burst of segments, and then no data and the burst of segments. So yeah, so basically the tool is really to see what's inside the FLUTE stream, see what are the characteristics of the transmission. Also, if everything is received correctly, to check the parameters. So it's really useful in that case. What I can show you next is maybe to use a bit more complex stream. So here it's one single FLUTE stream, but I can actually run a NIP stream with many other sessions. I will go back to the terminal. I will stop the MPS TF. Then I will start actually DVB-NIP server instead. So if I go back to the tool, so then the tool is detecting a new FLUTE stream here. And this FLUTE stream is actually have many different sessions. So here we got like 25 FLUTE sessions that are running in parallel. So no, it's not 5G-MBS anymore. It's the DVB-NIP, but anyway, we are sharing the same transport layer. So with this tool, there is a multicast. Multicast transport station object that is actually defined in DVB-MABR, and this file is describing all the FLUTE sessions that are available in this NIP stream, and that you can actually join to get access to the data. So there is, for example, this FLUTE session that is actually announcing other FLUTE sessions, and these FLUTE sessions here are dash services, actually dash and HLS. So here I've got, for example, this service that is called B1, which is a dash stream. So again, I can monitor the bitrate. So what we are doing here is that the tool is able to give an idea of how long it takes to zap to this NIP stream. and to acquire the minimum set of files to start the playback. So for example, if you want to watch B1 and use up at that specific moment, you need to wait to acquire a full burst. And once you got this burst, then you can start the playback. So actually, we are measuring that you need at least 0.5 seconds of data to start your playback. If you are missing the burst and you use up here, then you are missing the file. You need to wait for the next burst of data, and then you need to wait like 2.5 seconds before you can actually start the playback. This is what the tool is measuring here. This live stream is actually splitted into several sessions. So there is here one FLUTE sessions that is dedicated to the signaling of the MPEG dash. So this FLUTE session is containing manifest and the initialization segment. And then there is one FLUTE session per representation. So there is one FLUTE session that is transporting the FD video, one that is transporting the HD video, and another one that is transporting the audio. So before, in the previous, in the MBS FT, we were using only one FLUTE session to transport everything. Here, with this NIP demo, we are splitting the different components of the live stream to different FLUTE sessions. Again, if I open the manifest, then actually the tool here will actually give me some information about how long it takes to zap, and will tell me, okay, so if you are zapping at that specific moment, then you will acquire the following files. So this segment, this SD segment, this audio segment, HD segment, the manifest, the initialization segment for the HD audio and SD, and then you've got enough enough data to actually start your playback. In the worst case, this is the worst case. You will have to wait a bit more to acquire everything. So in DVB-NIP, we can actually apply some offset to the dash clock, so that the segment are in line with the manifest. So for example, here we are applying an offset of 3 seconds and a half. We are delaying actually the manifest by 3 seconds and a half. This is actually this delay is introduced by the DVB-NIP server when we are transferring the segments. What I can show you. Okay, so if I open, for example, this FLUTE stream, then you will see that here we are receiving again all the files that are transported by this session. So yeah, so I can, okay, guys, I can show you a bit more few files. So for example, here it's a NIP stream. So in the NIP stream, we are transporting many signaling files. And for example, we are transporting a file that is signaling some service guide and the content guide. So here it's a DVBI content guide that is signaled here. And we've got a session that is transporting all the materials relative to the content guide. So I will open this FLUTE session. So for example, this specific carousel is transporting basically images, and it's all the images for the DVB content guide, and the images here are transported one after the other. So we see each bar is actually a different image. One JPEG, another JPEG, one by one. So when a gateway is receiving this NIP stream and wants to display a content guide, that needs to acquire the full carousel of images to display correctly the content guide. And these images are actually repeated. So it's really in carousel. So we are transporting images one by one, and then the next one is the images repeated again and again. I've got some other carousels that are transporting here I've got covers, PDFs, for example. So okay, the file are a bit larger, but yeah. So here we are receiving PDF files. Here we are transporting covers PDF, so it's against images. So if I click on one image, we see that this same image is actually repeated over and over. And again, we can have access to the different transmission information about this file.